2b, subtraction of whole numbers and decimals. So subtraction is taking away or undoing addition. If you added 1 plus 2, you got 3. If you do 3 minus is another word for subtracting, 3 minus 2 is 1. 1 plus 2 is 3, 3 minus 2 is 1. 3 minus 1 is 2. Right? So it's basically undoing addition. The result of a subtraction problem is the difference. And you're familiar with that. If someone asks you what's the difference in how much you make and someone else makes, that's going to be a subtraction. If you make $400 a week and they make $300 a week, the difference is $100. So that's the result of subtraction called a difference. So let's start by getting a visual of what subtraction is. If I have 13 minus 7, 13 minus 7. Now you'll notice that when we were doing addition, I dealt with single digits first. Well, since subtraction is the undoing of addition, then we could start into double digits. It just means what we subtract will be a single digit, and the result or the difference will be a single digit, right? So I've got 13 minus 7. So I can draw those out. I go 13, okay, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm going to subtract 7 or take away 7. Well, if I take away 7, then I'm taking away 1, 2, 3, 4, 5, 6, 7. So I'm getting rid of 7 of those circles, leaving me with 1, 2, 3, 4, 5, 6. 6 circles left. And that's the process of subtraction. You're just starting with some amount, and then you're taking away some. If you have $10 and you give someone $4, how much do you have left? You have $6 left. That's what we're going to deal with. Now, I mentioned this on the addition video, and I'm going to mention it again here, that we need to be able to do simple subtraction, basically numbers that when you take away a single digit amount, leave you with a single digit amount. We need to be able to do those pretty much without thinking about it. So those math facts, which we talked about, are very important to us. So again, I'm going to point out factmonster.com. .com/math/flashcards. Okay, so an excellent site. There are many other sites, but this you can get in there and you can practice. So you can just say, okay, I want to do subtraction, I want to do a level 1, level 2, level 3, just some basic subtraction, and it will throw up problems and you can practice doing it. They're the subtraction tables that you dealt with back in elementary school. And remember, subtraction is just the opposite of addition. So if you can do your addition math facts, then these are just the opposite. If you know 7 plus 6 is 13, then 13 minus 7 must be 6, because that's what you add to 7 to get 13. So that's the idea. So it's good to get a lot of practice. Get where you can do these pretty quickly, where it doesn't take a lot of thought because you already know the answers. For those simple ones where you're subtracting a single digit and the result or difference is a single digit. So practice them, make use of them. Get it where they're in your head, because that's going to make your life much easier when we get into bigger problems. So let's get into bigger problems. What if I have 75 minus 32? So 75 minus 32. Now, subtraction, just like addition, we are going to stack them up, and line up the place values. So 75 minus 32. And so all I'm going to do is start with the ones place, or the rightmost column, and go 5 minus 2 is 3, because I know 2 plus 3 is 5. And then 7 minus 3 is 4, because 4 plus 3 is 7, right? So if we know our addition facts, subtraction should just come right along with it, because it's the opposite operation. So we know 75 minus 32 is 43. So, not bad. Let's go to a larger number, something more than 2 digits. $589 minus 451. So 589 minus 451. So we got 451, 589. Wrote that backwards just for the fun of it. So there we go. So now I'm just going to subtract. 9 minus 1 is 8. 8 minus 5 is 3. 5 minus 4 is 1. And so the difference between 589 and 451 is 138. So not too bad to go along with that, as long as we can take a single digit and subtract another single digit. And that's the nice thing too. It's like I showed, well, what if we have a double digit number and you subtract a single digit from it? Then you've got to know how to do that. But really, as long as you can subtract a single digit from a single digit, you're pretty safe. Now you'll see in the next thing I do that there's a reason we need to be able to do that double digit thing. So let's look at this one. And I'm just going to stack these this time because it saves me a little bit of writing as opposed to writing it out across and then writing it down. What if I have 253 minus 181? So now we see that we can go 3 minus 1 is 2. But when we get here, we see 5 minus 8. Now don't make the classic mistake of saying, oh, 5 is smaller than 8, so 8 minus 5 is 3. Don't do that because that's wrong. And it's a common mistake that I see. You're still doing 5 minus 8, but 8 is bigger than 5. So what we're going to have to do is we're going to do what's called borrowing. We're going to borrow from this next digit. And what we're going to do to borrow is we're going to say, well, 2, if I take 1 away from that, I can turn that into a 1, and I can put that 1 in front of my 5. 1 plus 1 is 2, so that's my 2 that was there. So now I have 15 minus 8. See where I said that we're going to need that two-digit number, you subtract a single digit from it. So 15 minus 8 is 7, and then 1 minus 1 is 0. So 253 minus 181 is 72. And we know this 0 is an unnecessary 0, so we don't really have to write that there. So it's just 72. Let's do another one. Borrowing sometimes throws people off, so we're going to do a few of them here. So let's say I have 1,486 minus 967. So what am I going to do? I'm going to go 6 minus 7. I go, I can't take away 7 from 6, so I'm going to borrow. I'm going to take 1 away from this 8, which is going to turn it into a 7. And I'm going to switch colors just so this is more visual here. So I'm going to take that 8 and turn it into a 7, and I'm going to give that 1 over to the 6, which now makes it 16. 16 minus 7 is 9. So now I have 7 minus 6 is 1. 4 minus 9, well I can't take 9 from 4, so I'm going to borrow from here. Well, that 1, that would make it a 0, so I can just leave it here. 14 minus 9 is 5. So I have 519. 1,486 to minus 967 is 519. Let's do another one. Practice. I heard recently that instead of saying practice makes perfect, practice makes permanent. So that doesn't mean that if we practice enough that we're going to be perfect at something. But if we practice something enough in the right way, we're going to make that right way permanent in us so that we will do it the right way in the future. So let's do another one here. 6,418 minus 2,743. So there we go. So 6,418 minus 2,743. Just to be consistent, I'm going to put my little comma there. So again, start the rightmost column, subtract. 8 minus 3 is 5. 1 minus 4, we can't do it, so we're going to take this 4 and turn it into a 3 and bring that 1 over here. So we now have 11 minus 4, which is 7. 3 minus 7, we can't do it, so we're going to borrow 1, making this 6 of 5, and putting a 1 here. So 13 minus 7 is 6, and then 5 minus 2 is 3. So 6,418 minus 2,743 is 3,675. So sometimes we have to borrow more than once, and that's okay. The process remains the same. So now let me show you something that may throw things off a little bit. What if I have 5,680, and I'm not going to put commas in this one, minus 2,468. So this one shouldn't affect us too much. We still have 0 minus 8. We can't do that, so we're going to borrow and make this 8 into a 7 and make that a 10. So 10 minus 8 is 2. 7 minus 6 is 1. 6 minus 4 is 2. And 5 minus 2 is 3. So 3,212. So not a lot of difference there. Same idea. I'm going to do something very similar to this next to it. And I want us to see the difference. What if I have 4,600 minus 2,398? Okay, it's kind of similar. The numbers changed a little bit. You had a 0 here, now we've got 2 zeros here. I just want to show what difference this makes when we start to do this. Because this is where people sometimes get a little thrown off. 0 minus 8. I can't subtract 8 from 0, so I'm going to have to borrow from this 0. Well, I can't borrow from 0 because 0 is nothing. So I'm going to have to borrow from this 6. So if I borrow from that 6, I get a 5, and this becomes a 10. Well, that's great. I've got a 10 here. I still need something here. I can't subtract 8 from 0. So what am I going to do? I'm going to borrow from this 10, which is going to turn it into a 9 and make that a 10. So you see what happened here? Because there was additional 0, I had to keep going until I didn't have a 0 anymore. I borrow from that. It gives me a 10, but since I'm going to borrow from that, it goes down to a 9, and this becomes a 10, and then I can subtract. So 10 minus 8 is 2, 9 minus 9 is 0. 5 minus 3 is 2. 4 minus 2 is 2. So we're at 2,202. No, I did not intentionally put all those 2's in there. Let's try that again, but I'm going to really accentuate this. $9 million minus 3,468,741. That's a pretty big number to be subtracting. And I start out, I go 0 minus 1, and I can't do it, right? You can't subtract 1 from 0, so I have to borrow. I can't borrow from that. 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 I can borrow from this 9. So I turn that 9 into an 8. And then this, I technically am putting a 1 there, right? But I need to borrow from that 10 so that I can turn this into a 10. So I'm going to borrow and make that a 9 and make that a 10. But now I need to do the same thing here. So I borrow from this and make it a 9 and make that a 10. I borrow from that, make it a 9 to give that a 10. I borrow from that, make it a 9 to make that a 10. I borrow from that, make it a 9 to make that a 10. And I am now down to where I can subtract 10 minus 1. So 10 minus 1 is 9. 9 minus 4 is 5. 9 minus 7 is 2. 9 minus 8 is 1. 9 minus 6 is 3. 9 minus 4 is 5. And 8 minus 3 is 5. So I have 9 million minus 3,468,741 is 5,531,259. Note here that this digit we turned it into a 10 by borrowing. All these other zeros became 9s. So we could actually save ourselves a little time and effort in this process by doing the following. If I start out with that 9 million again, I realize that I'm going to borrow and that's going to turn into a 10. All of these zeros are going to turn into 9s because I'm going to have to borrow from the 10s that they're going to become, and this one just ends up subtracting the digit. So I can save myself effort by just going, okay, subtract 1 from this, make these 9 until you come down to the end and make that a 10. Not only does that simplify our process here and save us some steps, but it can also help us to look like we're smarter than we really are. Let me show you an example. $70 million minus 48,276,394. That's a pretty big number to subtract. And you'll notice that for subtraction, we start from the right and work our way left. In this case, we know that this would, because we've got zeros here and we can't subtract 4 from 0, we're going to subtract 1 from this. So it's going to get reduced by 1. And then we're going to turn these all into 9s. And that last one's going to become a 10. So here's how we can look smarter than we really are. I know that this is going to become one number less. So it's going to become a 6. 6 minus 4 is 2. All of these are going to become 9s. 9 minus 8 is 1, 9 minus 2 is 7, 9 minus 7 is 2, 9 minus 6 is 3, 9 minus 3 is 6, 9 minus 9 is 0. And this one's going to become a 10. 10 minus 4 is 6. Don't I look smarter than I really am? I can go across and subtract this whole thing from left to right because I know the rule that this is going to get reduced by 1 because we're going to borrow it. These are all going to turn into 9s, and that's going to become a 10. Now, using it in this particular case may get a little confusing, but here's an example where this is very common, or actually, rather than doing it right now, in a little bit, I'm going to do an example where you're going to see this becomes really easy to use and really impressive to people who see you do it. So first, we're going to go to subtracting decimal numbers. So if I'm subtracting decimal numbers, again, just like addition of decimal numbers, it really doesn't change much except you have a decimal point. So if I have 56.7 minus 19.3 equals, I'm going to line up the place values, and then I'm going to subtract just the same as I did with whole numbers. 56.7 minus 19.3, 7 minus 3 is 4. We're going to put our decimal point because it's there. 6 minus 9, we can't do it, so we're going to borrow and make that a 4, which makes that 16. 16 minus 9 is 7. 4 minus 1 is 3. 56.7 minus 19.3 is equal to 37.4. The process really doesn't change. I am going to do another example because sometimes things look a little bit different. And this is just like an example that I did for addition. What if I have 34.6 minus 19.73? So 34.6 minus 19.73. Again, line up the place values. And that's where when we have decimal points, when we're dealing with decimal numbers, we can say line up the decimal point, and then all the other place values will line up without any problems. So I have 34.6 minus 19.73. Now something you may notice right away is that I have nothing minus 3 in that first column. So again, just like I did in addition, I'm going to fill in with zeros anything that I need to make sure that these match up and they have something to work with. So now I can easily see that, oh, 0 minus 3, I can't do it. I'm going to borrow, which is going to make it 5 and make that a 10. 10 minus 3 is 7. 5 minus 7, can't do it. I'm going to have to borrow, make that a 3, and turn that into 15. 15 minus 7, 8. Decimal point. 3 minus 9, can't do it. I'm going to borrow, make that a 2, makes that a 13. 13 minus 9, 4. 2 minus 1, 1. 34.6 minus 19.73, 14.87. So if we're missing a decimal place in one of them, feel free to fill it in with a 0 so that we can subtract. Otherwise, people get things misaligned. Remember, the place values have to match up. So now I'm going to go back to what I was saying. I was going to show you this little trick. What if I have something like 1 minus 0.6497? Now, that may look kind of complicated. We could draw that out as 1.0000 minus 0.6497. And then I can say, okay, well, that's going to reduce this down to 1 into 0. These are going to turn into 9s, and that's going to be a 10. So I could do that, and then I can subtract. 10 minus 7 is 3. 9 minus 9 is 0. 9 minus 4 is 5. 9 minus 6 is 3. 0 minus 0 is 0. And we get an answer. But here's where I said we have that little trick. That same thing that I used to subtract two very large numbers, I can use here. 1 minus, well, when I subtract 1 from 1, it's going to be 0, right? When I borrow from that. So I can just come across here and go from left to right, which, like I said previously, makes you sound smarter than you really are. And I say that to all of us. It makes us all seem smarter than we really are. My students in other classes are amazed at times when I can take a subtraction like this and I just go, oh, 1 minus 0.6497. Oh, that's 0.3503. And they think I just subtracted this thing in my head and gave them an answer because they're used to subtracting the other way and building it this way. But really, all I did was said 9 minus 6 is 3, 9 minus 4 is 5, 9 minus 9 is 0, 10 minus 7 is 3. So it's using the same methods that we just did. And this will come in really handy if you're dealing with statistics and probabilities, because you do a lot of subtracting from 1. And if you can learn a little trick like this, it'll just make your life a lot easier. Okay? What if we want to subtract multiple numbers? 56 minus 19 minus 25. So we want to subtract multiple numbers. We can only subtract one number from another number. We can't subtract 3 numbers at the same time or 4 numbers at the same time. So all we're going to do is work our way across and say that's 56 minus 19. 6 minus 9, can't do it. Borrow, we get 4 and 1. 16 minus 9 is 7. 4 minus 1 is 3, so we have 37. And then we're going to subtract the next one. 37 minus 25. 7 minus 5 is 2. 3 minus 2 is 1. So we come out with 12. So just work your way from left to right. 56 minus 19, get an answer. That answer, minus 25, gives an answer, gets us to 12. So that's how we do it if we're subtracting multiple numbers. Now I have one more thing I want to show to you, and this is a different method of subtracting numbers. Now this is known as the Singapore method. And it's a way that may or may not be useful to you. Personally, I don't use this method, but you may find it to be a little bit simpler. So it's up to you. And this method can be expanded out to be used no matter how many place values you're dealing with or how many digits in your numbers. 52 minus 37 equals. So here's the idea of the Singapore method. I'm going to stack these just like we have been doing. 52 minus 37. Now the problem we run into here is that 2 minus 7, we can't do it. So the Singapore method is a way of kind of avoiding borrowing, because what we're going to do is rather than trying to do this and borrowing, we're going to say, look at this bottom number. The reason we can't subtract 37 from 52 is because we can't subtract 7 from 2. So if we can turn this bottom number into a 0, it's easy to subtract 0 from something. It doesn't take anything away. So the Singapore method says, look at that bottom number and subtract it from both of those numbers. Minus 7, minus 7. So 52 minus 7, 45. 37 minus 7, 30. Now it's easy to subtract 45 minus 30. 5 minus 0 is 5. 4 minus 3 is 1. And the answer is 15. So I'm not going to go into great depth in this method because, like I said, I don't tend to use it. I don't really like it that much, but you may find that to be an easier way to do it. It's like, oh, well, I can subtract 7 from both of those numbers. Now you do it, and now you don't have to deal with borrowing. So that's the advantage of the Singapore method, is you don't deal with this borrowing thing. You just subtract the number from both of them, and now you can use numbers that work. Use it if you choose. I would never require anybody to use the Singapore method. So that's subtraction of whole numbers and decimals.